Hi guys, so today we're going to be doing a lab called To Break or Not to Break. And we're going to be looking to try to see if breaking up an antacid or Alka-Seltzer tablet affects how long it takes to dissolve. Right, so that is our testable or experimental question. Does breaking up an antacid tablet affect how long it takes to dissolve? So the first thing that we're going to do is we're going to read through our materials, we're going to read through our procedure, and then we will figure out what our hypothesis is, and we will figure out what all the different parts of our experiment are. So for the materials, we have 2 antacid Alka-Seltzer tablets. We have 2 cups that are filled with the same amount of water. Okay. We have 2 empty cups. We have a stopwatch, and we have a popsicle stick or scissors. And the procedure says that we are going to place each of the antacid tablets into its own empty cup. Then we're going to use the popsicle stick or scissors to break up one of the antacid tablets into small pieces. We want it crushed up as small as possible, and we're going to leave the other one whole. Then we're going to pour the water from one of the cups into the cup with the whole tablet. We'll time, as soon as we start adding the water, we'll time it, and we will record how long it takes for the tablet to fully dissolve when we can no longer see any solid pieces in the cup, and we'll record the time in our data table. Then we're going to basically repeat this in the cup that has the crushed tablet. We'll pour the water in onto the cup with the broken up tablet. We'll time how long it takes for the tablet to fully dissolve, and we'll record that in our data table. So the first thing that it asks us to do is to write a hypothesis. This year in science, when we write a hypothesis, we're going to be using the if, then, because format. So if this happens, then this happens because, and you give an explanation. So our if, we should be able to get right from the question, right? So if we break up an antacid tablet, then here's where your prediction comes in, right? Then you're either going to think that it takes more time to dissolve or less time to dissolve. So that's your choice. You get to choose. You'll write that in. If this happens, then it'll take more time or less time because, and then you have to give an explanation as to why that was your prediction. Why did you think it would take more time, or why did you think it would take less time? So everybody right now should go to their Google Doc and find the place where it says write a hypothesis, and you're going to type your hypothesis right now in that box. If we break up an antacid tablet, then, and you're going to decide, does it take more time or less time to dissolve? Because, and you'll give some sort of explanation why. It could be a personal anecdote, a story, some type of reasoning, but you're going to take a pause right now and you're going to go fill out that part of your Google Doc, write your hypothesis. Okay. Once your hypothesis is written, you are going to look at the chart that has the different parts of an experiment listed. So this is similar to what we've been going over in class lately, identifying what in your experiment is the independent variable, the dependent, the constants, the control. So the first thing that it asks us to find is the independent variable in this experiment. We know that the independent variable is the thing that we are purposefully changing between our 2 trials, right? So we're going to be putting an antacid tablet in both of these cups. One of them is going to be whole and one of them is going to be crushed. So that is the thing that we are purposefully making different between our 2 cups. So that's going to be our independent variable, right? Whether the tablet is crushed or not. So go write that into your Google Doc, right? Our independent variable is going to be whether our tablet is crushed. The next thing that it asks us to identify is our dependent variable. So for our dependent variable, this is going to be the thing that we're trying to see if it is affected, right? So by crushing one tablet and not crushing the other, we're trying to see if it affects how long it takes to dissolve, right? So that's going to be our dependent variable, right? The results that we're looking at. Is it affecting how long it takes to dissolve, which is a unit of time? So you're going to go open your Google Doc right now, and where it says dependent variable, you're going to fill in how long it takes to dissolve. The next thing it asks us to find is 2 constants in this experiment. There are more than 2, but it asks for 2. Constants, of course, are things that we keep the same between our trials. So you could say that we used the same brand of tablet, the same size of tablet, the same kind of tablet. You could say we used the same amount of water. That water was the same temperature for both cups. We could say that it was done in the same size cup, the experiments. So all of the things in our experiment that we're keeping the same, which are very important, are constants. So you can pick 2 to write in your Google Doc right now. So go over to your Google Doc, find constants, write in 2 things that we're keeping the same. Next, it asks for the control. So we said that the control in an experiment is the one that you use kind of as your comparison, and it's usually the situation that's as close to normal as possible. So if we think about our 2 cups that we're going to have, one is going to have an Alka-Seltzer tablet that is whole, and one is going to have an Alka-Seltzer tablet that's crushed. So when you think about using an Alka-Seltzer tablet, you generally just take a whole tablet, drop it into water, you let it dissolve. So we don't usually take time to crush up the tablet first. So our normal situation here would be our whole Alka-Seltzer tablet, because that is the kind of normal situation that we can use as a comparison. So for your control in your Google Doc, that's going to be the whole or non-crushed tablet. Then it asks us for 1 piece of qualitative data that we could collect during this experiment. So qualitative, of course, it's observation-based, which means that there are no numbers involved. It's based off your senses. So it could be something that you see, you smell, you hear, you taste, you touch. So it could be something like the size of the bubbles, or where the bubbles are as it dissolves. Are they mostly at the bottom? Are they mostly at the top? Does one have a smell that the other doesn't have? So you can pick 1 thing to focus on making observations for during our experiment. I might do like the size of the bubbles as mine. You can pick anything that you would like as long as it's an observation that does not involve a number. So you're going to pause, you're going to go back to your Google Doc, and you're going to type in a piece of qualitative data, some type of observation that you could make as this experiment happens. Then it asks for what type of quantitative data we could collect. So this is going to be number-based, okay? We know we, of course, have to record time, because if we don't record the time, we can't answer our original question. So your quantitative data that you're collecting could just be the length of time it took for each tablet to dissolve. It could be that you're going to get a thermometer and you're going to measure the temperature of the water as you do the experiment and see if it changes for the whole tablet versus the crushed tablet. So anything that involves numbers could be your quantitative data. So you're going to pause, you're going to go back to your Google Doc, and you're going to type in some type of quantitative data that you will collect during this experiment. Once your table is filled in, it is time to actually do the experiment. So once we've identified all of our parts, we're going to do the experiment. We're going to follow the procedure. As the experiment is running, remember that you want to be writing down some type of observation for each trial, and then also timing and recording the number that it took for each trial. So if we look back at our procedure, the first thing that it says to do is to take our antacid tablets and to place them both into an empty cup. So we put one in one cup, one in another. Then it says, using a popsicle stick or scissors, break up one of the antacid tablets into small pieces, as small as you can. So you're going to try to break this up. And again, it's not going to be perfect, but you're just going to try to break it into as small pieces as possible. Okay. So now you have 1 cup that has a whole tablet in it and 1 cup that has a crushed tablet in it with little pieces. It says pour the water from one of the cups into the cup with the whole tablet. So I'm pouring the water into here. Time how long it takes for it to fully dissolve, where you can no longer see any solid pieces. Record the time in your data table. So I'm gonna get my timer ready. So we're gonna get our timer ready. And as soon as we start to pour in the water, we will start our timer. So I'm adding this to the whole tablet. Okay, you can see it's bubbling, it's fizzing. Tablet's still there at the bottom. You can still see, okay, it floated to the top now. You can still see some whole pieces. You can hear it bubbling and fizzing. There's one little whole piece left stuck to the side. And stop. Okay. All right, so it has fully dissolved and our time was 41.86 seconds. So what you're going to do is you're going to go to your table on your Google Doc, and there's 2 different parts. The first part is qualitative data for the whole tablet. So any observations of things that you saw or noticed as it was happening. There was definitely a lot of bubbles. There was definitely, the tablet started at the bottom and floated to the top. There's still bubbles left on the side. You can kind of look at them and see them. So any of those could be observations that you write down. And then at the bottom table for quantitative data, where it says whole tablet and time that it took to dissolve in seconds, I'm going to write 41.86 seconds. Once you have that all filled out in your Google Doc, we can move on to the second part of the procedure. So the second part of the procedure is to have our crushed tablet, to take our other cup of water, to pour it in, and to time how long it takes for that to dissolve. So as soon as I start adding my water, I will start my time. Add in all the water. You can see there are some solid pieces floating through. They've kind of all gone to the top now. There's still some solid pieces on the side. And if I look, I would say it's done about now. So that was 31.07 seconds. Observations that we can make as we look, okay. There's still bubbles on the sides. The bubbles, you can compare them to the ones before. Do they look the same size, smaller, different? Are there less? Are there more? Definitely, again, the pieces started at the bottom. They floated eventually to the top. So any of these are observations that you could make. Did it sound louder? Did it sound quieter? Anything that you noticed. Right now, you can go to your Google Doc. In the qualitative table for the broken tablet, you can write anything that you observed. And then underneath it in the quantitative table, you can record the time that it took for the broken tablet to dissolve, which was 31.07 in this trial. Okay, now that our experiment is finished, okay, we have to compare our data, right? So our whole tablet took 41.86 seconds. Our broken tablet took 31.07 seconds. So now you have to make your conclusion. Okay, so if you look on your Google Doc underneath the data table, where it says conclusion, it asks you to highlight the word that is true, highlight or circle the word that's true. And the sentence says, breaking up the antacid tablet into smaller pieces will cause it to take, and you have to either highlight more time or less time. So you want to look at the results and figure out, did it take more time to dissolve when it was broken, or did it take less time to dissolve when it was broken? And you're going to highlight whichever of those statements is correct. And then you're going to compare it back to your original hypothesis. Okay, so each of you at the beginning of this experiment made a hypothesis that was your own, whatever your educated guess was. So now you're going to look back at your hypothesis, you're going to compare it to your results, and you're going to say if your original hypothesis was either supported or unsupported. So if it matched your hypothesis, you're going to highlight supported. If it didn't match your hypothesis, you're going to highlight unsupported. I want to make this very clear. Your hypothesis does not have to be correct. Okay, in this class, your hypothesis never has to be correct. You do not lose points. You should not go back and change your original hypothesis to match your results, right? A hypothesis is just an educated guess, okay? So it's a guess, right? 50% of the time, you're probably going to be wrong, and that's totally fine. But we never go back and change information, change data, change hypothesis. So you just look and say, did it match or didn't match? If it didn't match, that's totally fine. If it did match, also totally fine. You just want to highlight whatever is true, if it was supported or unsupported. So this is the end of our first kind of mini experiment where we're identifying the different parts and then collecting a little piece of data. We'll do a couple more of these in the next couple of days to just practice going through the different parts of an experiment.